Hi, I'm going to be going over the umpire process for delete, append, sort. So the problem states that you recently learned a new way to sort an array of numbers in your algorithms course. The algorithm sorts an array of numbers by repeatedly performing the delete and append operation. The delete and append operation consists of three steps. Choose an element from the array, delete the chosen element from the array, append the chosen element to the end of the array. Being a curious student, you wonder what is the minimum number of delete and append operations required to sort a given array. So given an array of integers, find out the minimum number of delete append operations that are required to make the array sorted. So starting with the understand step, so we're given an array of integers. We want to find out the minimum number of delete append operations that are required to make the array sorted. So then we want to find out the minimum. So this should be our output. So this is our input. And then our output should be the minimum number of operations then to make the array sorted, right? So we're also given two hints. Could you somehow find out how many operations are necessary by looking at the already sorted version of the array? And alternatively, it is possible to find out the minimum number of required operations without sorting the list. So we don't have to sort the list to find out all the minimum number of operations, and then also we can look at the already sorted version of the array to find out how many operations are necessary. So given the first example, so for our input, we're given 1, 5, 2, 4, 3, 6. Then the output is 3. So starting array, and then we have 4. So as our first one, so 4 moves to the end. And then 5 moves to the end, and then 6 moves to the end, so that gives us 3 operations. In terms of matching, I haven't seen this specific problem before, but we have been doing a lot of sorting problems in this module. And I also have been working on this problem, so I do have an idea of what to do, so I think a stack would be best. Comparing, we'd also need like a minimum number, or minimum variable. So in terms of my plan, I'm gonna create an empty stack, and then this will keep track of ordered elements, like the longest sequence of ordered elements in the array. Then I want to create an empty minimum variable. So this variable will keep track of the minimum out of order variable in the array. Then I'm going to loop through the array. I want to check if the stack isn't empty, and if current element in array is less than the last element in the stack. So if it is, and minimum hasn't been found yet, or current element is less than minimum, then I want then the minimum will equal will be the top element of the stack. Otherwise, just pop the stack. every time loop runs, I want to add a current element of the array to the stack. And then after this, I want to check if the last, because there will might still be numbers in the stack, so I want to check if the last element of the stack is greater than minimum. If it is, pop the stack. Then I want to subtract, return and subtract length of the array minus length of the stack. So yeah, I think the way this works is that we're keeping track of the longest sequence of ordered integers using our stack. Then every time we encounter a number that breaks that order, we delete it from the stack, and we compare it also against like our minimum out of order element if we have one. Then after that loop, we might still have some integers that are larger than our minimum variable, and if they are, we want to take those out of the stack also. Then after all of that, we subtract our array by our stack, and then that will give us how many operations are needed to sort the array. So yeah, so now it's the implement stage. So I'm going to create the stack first. So in order, so I'm just calling it in order was empty, and then minimum can be 0. Or yeah, I think 0 should be fine. So we're going to loop to the array, and while so we're going to check if the length of, so if we have something in the stack so it's greater than 0, and if the current element that we're looking at is less than the top element of the stack. And if it passes that check, then we want to check that minimum, I think we can use 0, let me see. I guess none would be better, maybe just to be safe. Oh, we're checking if it is none, my bad. Is none. So if we don't have one yet, then we don't have a minimum yet, then we want to have a new minimum variable. So if it's none, or if we find a smaller number in our array, then we want minimum to be the top element of the stack. Otherwise, we just pop the stack, because we still found a unordered element. Yeah, we still found a unordered integer in the array. And every time we want to make sure that we're adding everything that we see in the array to the stack. Yeah, then so at the end, we might still have numbers in our stack, and we just want to make sure, we want to check if they're greater than the minimum value that we have. So we check the top of the stack, we see if it's greater than the minimum that we currently have. If it is, we pop the stack. And then finally we subtract the length of the array minus the length of the stack. Okay, so I mean, I want to do a review, but also I just want to make sure. Yeah, so I'll do the review first. So the review. So we have the first. I'll do the example. So we have we're given 1, 5, 2, 4, 3, 6 for nums array, and then so going through the code in order should be empty, right? We'll keep track of that, and then we have minimum equaling none. So for I and nums, so I is 0 while len in order is none. Well, len in order is none. I think this is incorrect. I think I want to check that we do have something in the stack. That's my mistake. So yeah, we want to check if we do have something in the stack. Well, so we don't have anything in the stack right now, so this is going to pass. So we just add the first element of our array into the stack. So we have 1, and then I becomes 1. So we do have something in the stack now. And while so we're on 1. So now we're looking at 5. So while 5 is less than 1, so it's not, so this doesn't work. So we just add 5 to the stack. Okay, and then now I becomes 2. So our stack isn't empty anymore, and then we're checking if 2 is less than 5, and it is, so this passes. So we don't have a minimum yet, so minimum equals in order.pop, so minimum will be 5. And we're looking at 2 now, so now we add 2 to the stack. So I becomes 3, now we're looking at 4. So we have something in our stack, and then while 4 is less than 2, it's not. So we just add 4 to the stack. And now I becomes 4. So we have something in the stack, and while 3 is less than 4, it is. So we have a minimum now, or while 3 is less than 5, and it is. So our minimum equals in order.pop. So we take out 4, and then our new minimum becomes 4, and we add 3 to the array. And 1, 2, 3, 4, now 5. So we're looking at 6. So we have something in the array, or in the stack. And then while 6 is less than 3, it's not. So we just add 6 to the stack. Then we have this final check. So while in order -1, so while 6 is greater than 4, and it is, we just take it out of the stack. And then we do this again, while 3 is greater than 4, we just take it out of the stack, but it's not, so this doesn't run. So then we just do return len nums. So len of nums is 1, 2, 3, 4, 5, 6 minus len of our stack, which is 3. So we have 3 minus 3, and that's what we want. So yeah, looks like this works. So I'll go ahead and run it. Yeah, so I've been working on this problem a bit. I've been getting this error. I don't know why exactly, but oh, well, actually, I'm getting a different error this time. I in order. Let's see. Oh, can't go back. Well, is not none. I is less than in order -1. Oops. I is less than in order. Usually I'm getting the error right here, but so let me check. Oh yeah, getting a different error now. Let's index out of range. See, this thing's kind of not working. Well then in order. I mean, this shouldn't be a problem, but let me try doing this. Okay, well this is running now, so that's good. And then I'll check this. Yeah, so this is actually the error I've been getting usually. I don't know why, like, it doesn't actually make sense when I think about it, because let's say I just, because the only reason I'd be getting this error is if there's nothing in the stack, but then if I run this, like it works, so that means there is something in the stack because it's reading len in order. And I'm still getting numbers right, so I don't know why why this is happening, to be honest. I think it might be like a bug with code check, but I'm not really sure. But what I'm hoping this works again, but let's see. What I've been trying to do, I just put if statement. So if in order -1 is greater than minimum, in order dot pop, and if in order -1 is greater than minimum, and then in order is greater than 1, we just want to pop again. So let's see if this works. In order, oh, now I'm getting an error. Or in the minimum, in order dot pop. In order, let me try. Yeah, so I don't know why I'm getting this error, because this doesn't actually make any sense, because this part works. So let me see. See what happens if I comment this out. Yeah, I'm still not getting it. don't know, this error, like, I'm not really sure why I'm getting it, to be honest, but if I print, if I print it, like, I think there's still an array here, or still something in the stack. Oh, well, I'm like, now I'm not getting anything, but if I print this, maybe. I wonder if I take out all this too, maybe it's causing it to mess up more, but I don't know. Let's see. This thing's not working. Yeah, like my error doesn't really make sense because if I take out the print statement, then like it works, I think. Yeah, and you can't do, I mean, unless it's just like 0, but let me see. Oh, maybe that is what's happening. It's just saying that in order 0. I don't know if I just do -1 if that'll work, but oh yeah, well that passed. But yeah, I'm not really sure why it's saying that it's empty. Minimum for I and nums. Maybe because I left that. Let me see. Let me see if I can get it this time. Oh yeah, this index. Remember when I tried if statements was working earlier, so let me try that too. Yeah, this isn't working. Minimum, let me see. Maybe I have my if condition correct. Let me try that. Minimum is none. Yeah, still empty. I'm not really sure why this keeps happening. Maybe I'll try printing it on every iteration of the while loop. Yeah, I'm really getting it still. So in order -1, minimum is less than minimum. Minimum equals in order dot pop. Yeah, I think this should be working. I don't know why I'm having problems with this. Yeah, I'm not sure. I think it might be something with code check, but I'm honestly, I don't know. Because I think this runs correctly. I'll try Python tutor too. Let's see. Order so -1 is greater than minimum. Then we just want to pop top of the stack. Yeah, so I'll try Python tutor one more time too, but I'm not really sure like what's happening exactly, because I think it should be working. And then let's define main. I just want to print. Oh, well, I need the array first. Let's see. And 5, 2, 4, 3, 6. Or I guess I'll try with the code check. 2, 5, 4, 1, 7. Print nums or da sort nums. That column over here. Okay, let's see how this goes. Oh, getting the same error here. Well, why though? Okay. Print da in order. Nums. Non-I. Why is I2? Oh, it's saying that's the value, so I is 2. Oh, it's not adding it for some reason. That's weird. I have no idea why it's happening. Oh, I just had a syntax issue. Okay, so I was just having syntax problems, but yeah, looks like this works. Yeah, so I think you um, yeah, you're just like checking you're using this stack to get the longest sequence uh, of like ordered elements in the array, and then you keep track of the minimum value, and you just check like when you keep adding elements to the stack, and you check when there's like an element that like breaks the like ordered sequence, and when there is, you like pop it from the stack and you try to check if it's your like minimum element that you have so far, and then you do this final comparison at the end to make sure that nothing is bigger than your minimum element, and minimum value, and then you just what's it called? You just subtract the length of the array minus the stack, and that'll give you how many operations are needed to sort the array. So in terms of time and space complexity, this runs in OVN, I believe, because it just depends on the length of the array. And then the space, I believe, is also OVN because you're using the stack, and maybe the stack will have like the stack will go through like every element in the array, and you're also the stack will go through every element in the array, and like maybe you'll have all the elements of the array in the worst case scenario. So yeah, thank you. That's my umpire process for delete, append, sort.